Today's lesson, we are graphing power and radical functions. So we're kind of leading into polynomial functions, but everything today is a single term, and we're just looking at different types of exponents. So starting out, we're looking at when the exponent is positive, and then even versus odd. So an even exponent, I'm going to look at ax squared, ax to the fourth, ax to the sixth. So all these even exponents, when you have just a single term, a monomial, they all kind of mimic that x squared, the parabola. So you have a parabola that opens up or a parabola that opens down, open up when the leading term is positive versus negative. So let's look at f of x equals 1/2 x to the fourth. So even exponent, leading coefficient's positive. So I'm just going to have a parabola that opens up. Let's just make an xy table, get some points. So plug in 0, I'm going to get 0. Plug in 1, 1 to the fourth power is 1 times 1/2 is 1/2. So over 1 up half, and you can reflect it. If I go 2 to the fourth is 16, and then cut that in half, I've got 8. 10, 9, 8 right here, and reflect it over. Okay, now looking at odd exponents, so if I've got ax to the third, ax to the fifth, ax to the seventh, when it's just a single term monomial, they all kind of mimic that cubic function that does this. And that is when a is greater than 0. If the leading coefficient is negative, it just changes the end behavior, just kind of flips it. All right, so let's graph f of x equals negative x to the seventh. All right, if I plug in 0, I'm going to get 0. If I plug in 1, I'll get negative 1. If I plug in negative 1, I'm going to get positive 1. And then plug in 2, I'm going to get negative 128. It's like shooting right off my graph. So those 3 dots, you just have to understand kind of how to draw it, that it's going to shoot way up, but then it kind of does this little curve thing like that. Okay, now looking when the exponent is negative. So if I have ax to the power of negative 2, negative exponents we would send to the denominator, and they become positive. If I have ax to the negative 4, that would be a over x to the fourth. So here is an example. F of x equals 3x to the power of negative 2. So first I just want you to rewrite it. So it's 3 over x squared. So that's like a rational function. I have a vertical asymptote right at 0. And then I'll also have a horizontal asymptote at 0. So let's make xy table and see what happens. All right, if I plug in 1, 1 squared is 1, 3 divided by 1 is 3. So right 1 up 1, 2, 3. What happens when I plug in negative 1? When you square negative 1, that goes to positive 1. So this is also 3. Negative 1 is also 3 up here. Okay, let's plug in 2. 2 squared is 4. And then 3/4 is, so just 3/4, 0.75. And then if you plug in negative 2, you're going to get the same thing because when you square it, it goes positive. So what we end up getting is, it's like the rational functions we've been doing, but in this time it's just like reflected over the y-axis this way. And that is when the exponent is even. So now let's think about odd exponent. So a x to the power of negative 3, a over x to the third. Same thing if it was 5 or 7. So what I want to bring your attention to is we've been graphing in the form like 1 over x minus 2 and finding vertical asymptotes. What exponent is that? 1 over x is exponent 1. That's an odd exponent. So this is going to behave like that. So the function is f of x equals 3/4 times x to the power of negative 5. If you rewrite that, that would be 3 over 4x to the power of positive 5. So once again, I've got vertical asymptote at 0 and a horizontal asymptote at 0. But it's going to behave like those functions because if I plug in 1, I'll get 3/4. That's a weird 3/4. If I plug in negative 1 to an odd power is still negative, so then it would be negative 3/4. So I have them in these quadrants 1 and 3. And then just kind of a quick note, if a is negative, these would reflect over the x-axis, and same thing here. If a is negative, this would reflect down here, and this would reflect up there. Okay, last set of examples, rational exponents or fraction exponents. So I've got a, and then x to the power of 1/2. That is the same as a times the square root of x. A times x to the power of 1/4. That would be a times the 4th root of x. So when you have numerator 1 and an even root, they behave like the square root function. So remember the square root function kind of does this. But these ones are hard to recognize patterns because when the numerator is higher than 1, it doesn't necessarily follow this pattern anymore. So we're just going to have to find some points and see kind of what happens. So f of x equals x to the power of 5/2. So let's rewrite that as a root. That is the square root of x to the 5th. Now I'm dealing with an even root, so I can't pick negative numbers. Because if you square, or if you negative number to an odd root or an odd power is still negative, and I can't square root a negative. So let's start. I can do 0, 0. If I plug in 1, still get 1. Let's plug in 2. 2 to the 5th is 32, so the square root of 32 is about 5.6. Right here, so we can kind of graph from there. It goes like that. Okay, so now odd root. If I have a times x to the power of 1/3, that's the same thing as the cube root, and that goes 5th, 7th, and so on. So similar, if the numerator is 1, well, let's first think, okay, cubic function does this. The cube root function flips it over on the side and kind of follows that pattern, but that's only with a 1. So if we have a different number, it will follow a different pattern. Okay, f of x equals, let's do x to the power of 2/3. Rewrite that, that's cube root of x squared. So I can cube root both positives and negatives. If I'm squaring something, that always makes everything positive. So let's see what happens. Let's plug in 1. 1 squared is 1. The cube root of 1 is 1. Oh, let's do 0, 0, and then 1, 1. Okay, what happens when we plug in negative 1? When you square it, it goes positive. Okay, so I've got negative 1, 1. Let's do 2. 2 squared is 4. The cube root of 4 is about 1.5. If you plug in -2, it's going to be the same. I'm going to get an x value out here. 8's going to give us a nice number. 8 squared is 64, and the cube root of 64 is 4. And then if you do -8, it will also be 4. So this kind of does this graph. So there's your full video on just monomials with different exponents, positive exponents, negative, rational, kind of looking for patterns, making XY tables, and graphing. Good luck with your lesson.